Math 2, Unit 10 Review Worksheet. Number 1, graph f of x. The graph of f of x is shown. State whether each statement is true or false. F of x is decreasing when x is greater than 0. That's right here. That is true. The axis of symmetry is y equals 0. That's false. Y equals 0 is that line right there. The maximum value of f of x is 9. That is true right there at the vertex of 0, 9. 2, 5 is a solution to f of x. 1, 2, 1, 2, 3, 4, 5. That is true. Negative 1, 3 is a solution to f of x. Negative 1, 1, 2, 3. That is false. 3, 0 is an x-intercept of f of x. 1, 2, 3. That is true. 0, 9 is an x-intercept of f of x. 0, 9 is not an x-intercept, is actually the y-intercept, so that is false. The axis of symmetry is x equals 0. That's x equals 0 right there, and that is true. The vertex is at 0, 9. That is true. The value of x when f of x reaches its maximum is 0. That's true. Number 2, f of x in number 1 above, determine the domain of f of x. The domain of all general equations like that is all real numbers. The range, well, if it opens down like this one, it's always going to be y. Since it opens down, it's going to be as less than or equal to the y value of the vertex, which is 9. If it opens up, it would be y is greater than or equal to the y value of the vertex. Determine the rule for translating g of x equals negative x squared to f of x, which is right here. Well, g of x equals negative x squared would look something like this. The important thing is the vertex would be at 0, 0. So what they want to know is how do you get basically this vertex to that vertex? And how would we change the x value? We wouldn't change it at all, so the x stays the same. How would we change the y value? We would add 9 to it, so it's simply y plus 9. Select the values of the quadratic function k of x, or selected values of the quadratic function k of x are shown in the table. Sketch k of x and determine all of these things. So basically it's negative 6, negative 7, and then you have a x-intercept of negative 5, 1, 2, 3, 4, 5, 0. And then we have, let's see what's next, negative 4, 5, which is 1, 2, 3, 4, 5, right there. And so we know the graph is going to be going down like this, basically. And then let's see what we got here. We've got negative 3, 8. We can't do that. We can't do that one. We can't do that one. We can do 0, 5, though. That's at 1, 2, 3, 4, 5. And then we can do the let's see, x-intercept at 0, 1, or excuse me, 1, 0, and then 2, negative 7 would be here, so this graph looks basically like this. I guess we could probably put it up off the chart there like that. Okay, the x-intercepts of k of x are negative 5, 0, and 1, 0. And we really didn't even need to graph it. They're both right here, negative 5, 0, and 1, 0. The y-intercept of k of x is right there at 0, 5. But again, we didn't even need to graph it because it's right there. The value of x where k of x is at its maximum. Well, where's k of x at its maximum? Right there. So the value of x would be negative 2. The maximum value of k of x, right there, 9, the biggest y value. K of x is increasing when x is less than negative 2. And it's decreasing when x is greater than negative 2. Negative 2 is the x value of the vertex, by the way. Okay, moving on. Number 4, match the equation to the number that reveals the characteristics of the equation without changing the form of the equation. Okay, so this guy is the best for finding the zeros or the x-intercepts, which is right here. Okay, when it's in standard form, it's best for finding the y-intercept, which is the value of m of x when x equals 0. That's also known as the y-intercept, which means the vertex form is best for finding the maximum value. So it looks like it is 2, 3, and 1. All right, moving on. The best thing to do here is just to factor without these things and then plug in. So I know 2x times 1x would give me 2x squared. And back here I know it's either 1 times 15 or 3 times 5. I'm trying to come up with positive 7, so I can see that, hey, 2 times 5 is going to give me 10, and 3 times 1 is 3, and 10 minus 3 is 7. So it looks like I want a positive 10 and a negative 3. So it's 2 minus 3, 1, and positive 5. Over here, same thing. I'm going to go 5x and 1x will give me 5x squared. And over here I have 1 and 10, 2 and 4, 5. And I'm trying to come up with 51, so I know I need something pretty big. So I'm going to put a 10 here and a 1 there. That's 1x plus 50x is 51x, but I want it to be negative, so they both will end up being negative. So that's 5, negative 1, 1, and negative 10. All right, number 6. For each of the following, state the vertex and determine whether it has a maximum or minimum. Here the vertex is 5, 2. It opens down, so it's got to be, a maximum. This guy, the vertex is 5, 2, and it opens up, so it's got to be a minimum. Over here it is negative 5, 2. It opens up, so it's got to be a minimum. Number 7, for each of the following, state the axis of symmetry. All right, well, let's find the vertex here. The vertex here is negative 1, negative 3. Remember, the opposite of what it shows here. So that means the axis of symmetry is x equals negative 1. Here, the vertex is negative 1, 7, which means the axis of symmetry has to be negative x equals negative 1. Here, the vertex is negative 4, negative 9, which means your axis of symmetry has to be x equals negative 4. All right, number 8, determine if each ordered pair is a solution to the function y equals negative 3x squared plus 1. So we're just going to plug in. So here this goes in for y, so y equals negative 3 times x squared plus 1. Well, that means 1 equals 0 plus 1, so that's a yes. Over here, again, we have y equals negative 3 times x squared plus 1. So that is 37 equals 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 1 is negative 11. Okay, so we have y equals negative 3 times x squared plus 1, which is 11 equals 2 squared is 4. 4 times negative 3 is negative 12 plus 1 is still negative 11. So that's no, no. Finally, y equals negative 3 times x squared plus 1, which means 8 equals 1 squared is 1 times negative 3 is negative 3 plus 1 is negative 2. So that's a no. Number 9. Given the graph below, answer the following questions. The vertex, right there at 0, 5. The maximum or minimum value, well, it's a maximum at y equals 5. The axis of symmetry, easy, right there at x equals 0. Notice the maximum value in this case is right there, and the axis of symmetry is right there, the x value. The graph is increasing when x is less than 0, and the graph is decreasing when x is greater than 0. What is the transformation of the graph f of x to g of x when f of x is x squared and g of x is x plus 4 squared minus 2? So what we need is the vertex of each of these. The vertex of f of x equals x squared is just 0, 0, right there. And the vertex of g of x is negative 4, negative 2, which is negative 1, negative 2, negative 3, negative 4, negative 1, negative 2. So basically what we want to know is how do we get from here to there? If we think about it in this terms, and this is the best way to do it, how do we get from 0 to negative 4? Well, we subtract 4, so that's going to be x minus 4. How do we get from 0 to negative 2? We subtract 2, so it's going to be y minus 2. And this is the rule that we wanted. Okay, number 11, same thing. F of x to g of x. F of x is still x squared, but this time we have a vertex of 3, 1, which is 1, 2, 3, 1. So how do we get from here to here? That means how do we get from 0, 0 to 3, 1, oops, positive 1. But we want it in general terms, so we'll call, how do we get from xy to, so 0 plus 3, so x plus 3, 0 plus 1, so it's y plus 1. And there's your answer right there. Number 12. All right, so we could either graph this onto here or we can just find the important points. So right here, that is your y-intercept. When x is 0, you're at your y-intercept. Here's one of your x-intercepts because y is 0. There's your other one right there. And your maximum or minimum is, looks like it's right here. And you can see they're getting bigger till they get to 2 and then they start going down, so that is a maximum. And that guy is right there at 3, 2, so 1, 2, 3, 1, 2. And then we have a y-intercept at negative 2.5 right there. We have an x-intercept at 1, 0 and at 5, 0. And then this guy matches up at 6. So we have a parabola that kind of looks like this. But we really don't even need to graph it because which graph has the greater maximum value? Well, clearly this guy does, but we can see 2 is certainly greater than negative 2. So we will say it is g of x. The value of x when g of x is at its maximum, the value of x when g of x is at its maximum is 3. Because the vertex is 3, 2. Let me write that a little neater. So the value of x when g of x is at its maximum is 3. Is greater than the value of x when f of x is at its maximum. Well, the value of x when f of x is at its maximum is also 3. So that's a no. The value of x when g of x is at its maximum is greater than the value of x when f of x is at its maximum. They're both 3, so it's clearly no. State the x-intercept of g of x. Well, it's right here and right here, so 1, 0 and 5, 0. State the zeros of h of x equals x squared minus 5x minus 14. Well, first we have to factor it. We get x times x is x squared, and negative 7 times positive 2 is negative 14. Negative 7 plus 2 is negative 5. So if we want the zeros or the x-intercepts, we plug in 0 for y. That means this has to be 0 or this has to be 0. Well, how do we make this 0? We set them equal to 0. And we solve for x. So we add 7 to both sides, we get x equals 7, which means one x-intercept is 7, 0. We subtract 2 from both sides and we get x equals negative 2, which means our other x-intercept is 2, 0. So it's 7, 0 and negative 2, 0. Number 14. A ball is thrown into the air and is represented by the equation h of t equals negative 3 times the quantity t minus 3 squared plus 23. where h of t is the height of the ball and t is the time in seconds. Find the time it takes for the ball to reach its maximum height. Really easy. Find the vertex, which is 3:23. Means it takes 3 seconds to reach a maximum height of 23. Time it takes to reach a maximum height, 3 seconds. What is the domain? The domain is basically 0 to 6 seconds. It takes 3 to get to the top and 3 to get to the bottom. That's your domain. 0 to 6 seconds. What is the range? Well, here it's at 0. It gets to a height of 23 and comes back down. So it's 0 to 23 feet. Moving on, number 15. Y equals -2 times the quantity x plus 1 squared minus 2. The vertex is -1, the opposite of what you would think, and right here, -2. The domain for any of these general ones is just all real numbers. And the range, well, we got to decide. This thing opens down, so we know the range is going to be y is less than or equal to -2. And the axis of symmetry is x equals -1. If we wanted to graph this thing real quick, we could take the -1, -2. We know it opens down, so let's just find out when y equals 0. Well, if we take y equals 0, we first add 2 to both sides, and we get 2 equals -2 times x plus 1 squared. And you know what, this isn't going to help, because when y is 0, we would be finding the x-intercepts, and that's my fault. We know it opens down, so this is my fault there. If we want to find the y-intercept, we plug in 0 for x, which is -2 times 0 plus 1 squared minus 2, which is y equals -2 times 1 squared minus 2. 1 squared is 1, and 1 times -2 is -2, and -2 plus -2 is -4. So that would be right there and right there. So we just graph this thing like that. Okay, number 16. All right, we want us to find the x-intercepts. Again, we can graph this, and we should factor this. We could factor it in with this negative, but we can also pull out that negative. And if we pull out the negatives, all of these would become the opposite. So x squared plus 4x plus 3, because -1 times x squared is -x squared. -1 times 4x is -4x, and -1 times 3 is -3. So now we just know this thing opens down, and that's all that negative really matters right there. Now when we factor, we get x plus 3 plus 1. 3 times 1 is 3. 3x plus 1x is 4x, which means when we set each of these equal to 0 and solve for x, we get x equals -3 and x equals -1, which means our x-intercepts are -3, 0, and -1, 0. So -3, 1, 2, 3 is right there, and -1 is right there. Okay, so we know our axis of symmetry is right between those guys, so we know our axis of symmetry is at x equals -2. Now this is where the one where the vertex is kind of hard to find. We have to take this y minus, and we're going to plug in -2, because that's what we know the x value of our vertex is. So we plug that in wherever there's an x in our general equation. So negative x squared minus 4 times x minus 3. So that's y equals -2 squared is 4, and -4 times -2 is actually +8. -4 times -2 minus 3. So we get -3 plus -4 is -7, and 8 plus -7 is 1. So we know that guy is there. And you know, we can plug in 0 for x again if we wanted and find the y-intercept. We'll just change that right there. and we go 0, 0, and we just get -3. So that's going to be there, which means we're going to have this guy as well. So we know our graph is going to look something like that. Pretty easy. This will always be your x-intercept or your y-intercept when it's in standard form. That's the nice thing about standard form. Okay, well, look at this. We got our y-intercept, don't we? It's -5. 1, 2, 3, 4, 5. So that's good. We got to start. Okay, let's factor it and find our zeros, or our x-intercepts. -5 times 1 is -5. -5x plus 1x is -4x. So we set it equal to 0, and we get x minus 5 equals 0, and x plus 1 equals 0, which means x equals 5 and x equals -1. So our intercepts are 5, 0, and -1, 0. So let's plot those. 1, 2, 3, 4, 5, and -1, 0. Okay. So let's find the vertex. Well, we got to find the axis symmetry. It's going to be right between these two guys. So 1, 2, 3, 4, 5, 6. So back 3, which means our axis symmetry is that x equals 2. Oops, I'm sorry. Down here, x equals 2. So now if we want to find the vertex, we have to plug this in for x and find y. So y equals 2 squared minus 4 times 2 minus 5. So y equals 4 minus 8 minus 5, which is y equals -9. So when x is 2, y is -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we know this guy is going to be here because it's a mirrored image. So we know our graph is going to look something like that. All right, number 18. Given f of x equals x squared and g of x equals 3 to the x, evaluate the average rate of change for f of x from 0 to 3. Well, here's f of x, so we simply plug in 0. So we have f of 0 equals 0 squared, which is 0. So that means 1 point is 0, 0. Okay, and f of 3 is 3 squared, which is 9. So our other point is 3, 9. So those are our 2 points when x equals 0 and when x equals 3. And they want the rate of change, or slope. So remember, the slope is y2 minus y1 over x2 minus x1. I'll write it right here. And we simply plug in 9 minus 0 over 3 minus 0, which is 9 over 3, or 3. So the average rate of change for f of x between 0 and 3 is 3. Now we'll do the same for g of x, which is g of x when x is 0 is 3 to the 0, which is just 1. And g of 3 is 3 to the 3rd, which is 3 times 3 times 3, which is 27. So our 2 points are 0, 1 and 3, 27. Again, using the slope formula, it's going to be 27 minus 1 over 3 minus 0, which gives us 26 over 3. And roughly we know that's 8 2/3, or 8.66. So clearly we know that 18b has the greater rate of change. So g of x will increase more rapidly than f of x. Something to that effect. How do the average rate of changes differ and why? Because x is your exponent up here, because g of x has x as an exponent, obviously that will increase much faster because it's an exponential equation. And we'll just put exponential equation. g of x is an exponential equation. Okay, moving on to number 19. The graph of h of t equals negative 16 times the quantity t minus 1/2 squared plus 36 models the path of the rocket's height h with respect to t time. Okay, let's choose true or false. The maximum height of the rocket is 36 feet. Okay, well, it looks like we're at 30, 32, 34, 36. This isn't a perfect graph because it should be, the maximum height should be 36, so that is true. Okay. Let's see, the maximum height is 2 feet. No, that's false. That's the time it's in the air. It took 2 seconds for the rocket to hit the ground. That's correct. We can see that right here, 2 seconds. That's true. The rocket started at an initial height of 30 feet. Now, that's false. According to this, it looks like it started at about, see, 2, 4, 6, 8. No, it looks like maybe, I don't know, about 32 feet, it looks like. So that's false. The rocket was increasing in the height between time 0 and time 0.5. So that is true. It's increasing right here. All right, find the zeros by the method of your choice. If there is no solution, write none. So we have a choice here of either solving or factoring. Whenever there is not an x to the first power, like here, 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 it's easier to solve. When there is an x to the first power, it's easy to factor. So I'm going to add 32 to both sides. I get 2x squared equals 32. I'm going to divide both sides by 2. I get x squared equals 16. I then take the square root of both sides. The square root of x squared is x. And remember, the square root of 16 is plus or minus 4, because if you plug in 4 squared is 16, and the square root of 16 is 4. Negative 4 squared is 16, and the square root of 16 is 4. So it could have started out as positive or negative. So your zeros are 4, 0, and negative 4, 0. All right, 21. We're going to add 49 to both sides. We get x minus 1 squared equals 49. We take the square root of both sides. We get x minus 1, because the square root of x minus 1 squared is just x minus 1, equals plus or minus 7. Now we add 1 to both sides, and we get x equals 1 plus or minus 7. 1 plus or minus 7, which means x equals 1 plus 7, which is 8, or it could equal 1 minus 7, which is negative 6. So your zeros are 8, 0, and negative 6, 0. All right, same thing, no x to the first power, so we will solve. So I'll subtract 50 from both sides. I get negative 2 times x plus 3 squared equals negative 50. Divide both sides by negative 2. Those cancel. We get x plus 3 squared equals 25. We take the square root of both sides. The square root of x plus 3 squared is simply x plus 3. And of course, the square root of 25 is plus or minus 5. I'll subtract 3 from both sides, and I get x equals negative 3 plus or minus 5, which means x equals negative 3 plus 5, which is 2, and negative 3 minus 5, which is negative 8. So our zeros are 2, 0, or negative 8, 0. Okay, finally, this one has an x to the first power, so we're going to factor it. We're going to factor it into two binomials, which means x times x is x squared. Well, 40, it looks like it's 4 and 10, and I'm going to go negative 10, positive 4. Okay, and these are equal to 0. So we said each factor equal to 0, negative 10 equals 0, and x plus 4 equals 0, which means x equals 10 and x equals negative 4. So our zeros are 10, 0, and negative 4, 0. All right, finishing up with number 24. So first we look for the differences. If that doesn't work, we look for the multiples. If that doesn't work, we go back and look for the second differences. So here I can see that we are going 1 times 3 is 3, and 3 times 3 is 9, and 9 times 3 is 27. That is clearly an exponential model. Oops, sorry about that. Exponential. Okay, 0 plus 3 is 3, 3 plus 3 is 6, and 6 plus 3 is 9, plus 3, plus 3, plus 3. That is clearly a linear model when you're adding constantly. And let's see, we look at this and we go plus 3. Plus 3 is, oh, that doesn't work. How about times 3? That doesn't work. So we check out the first difference. 0 plus 3 is 3. 3 plus 9 is 12. And 12 plus 15 is 27. And then we check the second level. 3 plus 6 is 9. And 9 plus 6 is 15. When the second difference is the same, we know it's quadratic.